back, children. Today we are going to discuss a very important topic, that is normal. Let's define normal by the help of a diagram. Let's suppose this is my Cartesian plane and I have a line in it. Now, the perpendicular length from origin to this line is your normal. That means normal is a line which is perpendicular to the given line. And here, since I am taking it from origin, so let it mark as small p. That means the length of the perpendicular is p. And this normal makes an angle omega with your positive x-axis. That means it moves in a anti-clockwise direction. Let's suppose I want to find out coordinate of q. Then how I am going to find out coordinate of q? Obviously, I will be dropping a perpendicular on x-axis and then I will be applying my trigonometric rules. So if I want to find out coordinate of q, then I should be knowing this length, and to find out coordinate of y, I should be finding out this length. So this is your right angle triangle. So OAQ is your right angle triangle, and if I want to find out length of OA, then obviously I will be writing it as OA by OQ. This is your perpendicular, so this will be your hypotenuse. This is your omega, that means the angle, that means this will be your perpendicular and this will be your base. That means I have written it as base upon OQ. OQ is what? H. And you know by the concept of class 10 that B by H is what? Nothing but cos of omega. Omega is just the representation of angle. As you write theta, alpha, beta, here I have written that angle, I have represented that angle with omega. You can take it anything. You can take it theta, alpha, beta, gamma, neta, whatever you want. Okay. So omega is nothing new to you. It is just representation of an angle. So here if I want to calculate the value of OA, and since I know length of OQ, which is P, so I can write it as OA upon P equal to cos omega, or I can say OA equal to P cos omega. That means length of OA is P cos omega, and which is nothing but your x coordinate. That means the distance of this point from origin is P cos omega. That means your x coordinate here is P cos omega. Let's find out its y coordinates. So for y coordinate you require this. So which two sides you will be considering? One which you want to find out and one which is given to you. So I will be taking the ratio of these two now. Now see, if this is omega, that means this is perpendicular. So if I want to find out QO, then I can write it as QA upon OQ. So QA is what? This is P perpendicular because this is opposite to your omega, that is angle, and opposite to 90 degree it is your hypotenuse. And you know P by H is what? This is simply sine omega. Since you have taken angle as omega, that's why I am writing here omega. So here if I want to find out QA, then obviously I will be writing OQ, value of OQ is P equal to sine omega. So it will be OA equal to P sine omega. That means this distance QA is P sine omega. So these are the coordinates of your point Q. Now if you want to find out, these are the coordinates of point Q, and if you want to find out the equation of your normal, this is your normal. If you want to find out equation of normal which is passing through P cos omega and P sine omega, then obviously you will be using your formula, which is y minus y1 equal to mx minus x1. Alright, now what you have to do? You have to just put the values of x1 and y1. This is your x1, this is your y1. And then what is the value of m? M is what? M is the slope of the line. So what is the slope of this line? The slope of OQ will be minus reciprocal of the slope of AB. Let's suppose this is your LM. So whatever we have slope of LM, since these two lines are perpendicular, so from perpendicular condition we know m1, m2 equal to minus 1. So find out the slope of Lm. So first of all we'll be calculating slope of Lm. So slope of line Lm will be what? Slope is given by y by x. So what is your y here? P sine omega. So I will be writing it as P sine omega. I am writing, since I know m equal to y by x, so I am just putting the values of y coordinate and x coordinate. So this is your slope of Lm. If you want to find out slope of OQ, then by your perpendicular lines condition, you can write it as, if slope of this is m1, which is sine omega upon cos omega, then this will be minus 1 upon sine omega upon cos omega. That means negative of reciprocal of this. So I am getting this as, this is equal to minus cos omega sine omega. So this is the value of your slope, or I can say this is your slope of normal. So if I want to frame equation of normal, then I will be using my equation 1. Equation of normal is given by here y minus y1. What is your y1? P sine omega equal to, what is your m? This is minus cos omega upon sine omega. Here you will be writing it as x minus x1. And what is your x1? This is P cos omega. So this is your equation of normal, whose slope is minus cos omega upon sine omega. On further simplification, that means if you multiply this sine omega this side, then this will become y sine omega minus P sine square omega, and here you will get minus x cos omega plus P cos square omega. You will be then taking P cos square omega and P sine square omega to one side, and it will convert into 1. So finally, after solution, you will get your equation as x cos omega plus y sine omega equal to P. So after solution, you will get the simplified form, and which will be x cos omega plus y sine omega equal to P. You need to do nothing, but you need to just cross multiply it. I think you cannot see there, so I am writing here. So the simplified form will be x cos omega plus y sine omega equal to P. So this is your final equation of normal. You just have a look.